Hi guys, this is going to be lesson 10.6. I actually don't have a video for 10.5, so don't think that you're crazy and that you missed one. We're not going to do that section, or if we do that section, we'll do it in class. So what I would like you to do is write down the question of the day, and it's just practicing solving expressions. Remember, expression is where you have a variable, no equal sign, but you can plug in something and solve for it. So we're going to be doing quite a bit of that in this lesson. And so I would like you to try those. Last thing that we looked at was section 10.4, and we talked about square roots. So just to review, certain equations are easy to find the roots and to find the quadratic, how to graph it by just solving the equation. So when you solve this, we can find the roots, or the zeros, the 0 points of the parabola where it crosses the intercept. So then we got to square root both sides. In this one, when we do this, we have to approximate the roots. We don't get the exact answer, do we? We get 2 roots, which would be 3 plus the square root of 5 and 3 minus the square root of 5. All right, at this point we have 2 roots, but we can't say exactly what they are. I mean, that's the exact answer. But when we have been, what we've been doing with these is we've been estimating to the nearest hundredths. So this is actually the most accurate answer we can get. All right, so if it just says it wants an exact answer, leave it at this point. If it says to round it, then you can go ahead and put it in your calculator and get the answer, the solutions, estimated solutions, okay? All right, we're finally here, and this is super fun. The quadratic formula is a really famous formula. It's actually in my math course book, and I've shown it to you. But this formula looks so crazy hard, but you're going to have it memorized probably after one day. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. And what this finds is it takes the actual a, b, and c values of a standard quadratic, and you plug in the a and the b and the c value into this, and it will find the roots. The roots that I'm talking about are where the parabola, the quadratic equation, where the parabola hits the x-axis. Oh, that did not curve. Okay? So, that is crazy, but this is the most accurate way, and if you can't use any of the methods that we used previously, and which we're going to talk about today, is, you know, we've done the factoring, we've done the square roots, we've done graphing, we've done a lot of different techniques, but this is kind of your standby. If everything else, if you can't figure out anything else, always you can come back to this quadratic formula, work on every single situation. Okay? I just wrote it a little bit nicer, or typed it for you. And the one thing that cannot be true, the one thing that we can't have, is this inside of here, inside of the square root. It has to be positive. See how it says b squared minus 4ac has to be greater than or equal to 0. It could be 0, but it can't be negative. Okay? All right, let's try our first one. I'm so excited. So I hope you guys are too. First thing we're going to do is we're going to notice that it's not in standard form, so we have to rearrange it. And then I'm going to state what a, b, and c equal. A is 3, b is 5, and c is negative 8. Okay? Now we're going to write the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then I put in b, I'm going to get negative 5 plus or minus 5 squared minus 4 times 3 times negative 8 all over 2 times 3. With me still? We just plugged everything in. Now we have to use Aunt Sally's rules. And I usually start inside the parentheses, or inside the quadratic, and I get square root of 25 minus, but it's gonna, because I have negative and negative, I'm gonna get plus, and then 12 times 8 is 696, plus 96, plus or minus, plus negative 5 all over 6. Alright, so this equals x. And we're going to get two roots because we have a negative 5 plus this divided by 6 and negative 5 minus this divided by 6. Let's see what this is. Negative 5 plus or minus. What is 25 plus 96? 121. Woohoo! It's a perfect square. We're excited, right? So we get x equals negative 5 plus or minus 11 all over 6. So we're going to get negative 5 plus 11 over 6 and negative 5 minus 11 over 6. Okay, we're going to get two roots. So this one is going to be 6 over 6, which is 1. And this one's going to be negative 16 over 6, which is negative 2. And 4/6, which is negative 2 2/3. Did I do that right? 12, 4 more. Yep. So my x values are 1 and negative 2, 2 2/3. So what that means is on our graph, we have no idea what we haven't found our vertex and our line of symmetry, our axis of symmetry or anything, but we found our roots. Our roots are 1 and negative 2 2/3. So we know that's happening. We also know that it's opening upward. So our vertex is somewhere down here in the lower quadrants. But right now we're just focusing on finding our roots. So there you have it. Okay, I would like you to try this one on your own. So go ahead and pause it. All right. You're going to first move the x. Get it set equal to 0. Our A is 2, our B is negative 1, and our C is negative 7. We write our formula down, negative B plus or minus the square root of B squared minus 4AC all over 2A. Negative B is going to give me 1 plus or minus negative 1 squared, kind of in parentheses, minus 4 times 2 times negative 7 all over 2 times 2. So I'm going to focus in the parentheses in the square root first, and I'm going to get negative 1 squared is 1 plus 28 times 2, because I have negative 4 times negative 8, which is 28, and that's going to be 56 all over 4. Times 2 is 56, yep. So then I'm going to get that another step further. I'm going to get 1 plus or minus square root of 57 all over 4. Now, 57 is not a perfect square. Last time I was celebrating because I was like, woohoo, it's a perfect square when we had 121. But when we don't have a perfect square, it depends on what the directions say. But the directions might say, give me the exact answer. Well, that's your exact answer. So you have two solutions. X can be 1 plus square root of 57 over 4, or it can be 1 minus square root of 57 over 4. But a lot of times in the directions in the textbook, they're going to say round to the nearest hundredth. So if we do that, we're going to get 2.14 approximately, and the other one is going to be negative 1.64 to the hundredths, or to the hundredths place, yes. Okay? So depending on what the directions say, it depends on what your answers will be. All right. So far, what we've been doing in 9.4 through 9.9, we've been factoring. Use when a quadratic equation can be factored easily. So it's kind of from the previous chapter was kind of foreshadowing for what we were going to do in this section. So a lot of the stuff we've been doing is, hey, if we can factor it, let's factor it. That'll find our zeros. Then we can find our axis of symmetry, we can find our vertex, and we can graph it pretty easily. In 10.3, we're graphing and then we're approximating solutions. That one we need to narrow it down and try to find what those exact roots are. And then in 10.4, we're finding square roots. That's what we just got done doing. Use when solving an equation that can be written in this form. 10.5 we skipped. 10.6, the good thing about 10.6 is we can use that on any quadratic equation. There's no limitations. So that's those are our choices that we've kind of been laid out to us, and it's really it's up to you which one you want to use and which one you feel most comfortable with. But I want you to practice so that you're comfortable with all of them, because sometimes the directions are going to demand you to do it a certain way. So keep practicing, keep asking questions, and remember, math is fun and the quadratic equation is helpful, not intimidating. Okay? Have a great night.